محمد وعلى آله وصحبه أجمعين. This is section 8.1. Chapter 8 is about systems of equations and inequalities, and we will start by systems of two linear equations in two variables. Okay, so if you have an equation like this, ax plus by equals c, the graph of this equation is a straight line. And if you have two equations like this, then you have a system of linear equations. So the graph of this equation is a line, so we call it linear equation. And if you have two linear equations or more, you call it system of linear equations or a linear system. Now, what is a solution to this system? Because always he will say solve the system. So how to solve the system? You need to find the solutions. So a solution to a system of linear equations in two variables is an ordered pair. Ordered pair means like this. So it's ordered pair x and y. So for example, 3 and 4. That satisfies both equations. So this ordered pair has to satisfy both equations in the system. For example, 3 and 4, this is an ordered pair, and it satisfies these two equations, because if you put x 3 and y 4, then 3 plus 4 is 7, and 3 minus 4 is -1. So 3 and 4 satisfies both equations, so it is a solution of the system. So this ordered pair is the solution of the system. So when he asks you to find the solution of the system, he needs this ordered pair, 3 and 4. A system of linear equations can have exactly one solution, like this system, 3 and 4. No solution, solution set could be phi, or infinitely many solutions. So there are 3 cases for any linear system. It could have one solution, no solution, or infinitely many solutions. We will study all of these 3 types here in this section. The first objective is to decide whether an ordered pair is a solution of a linear system. So he will give you a question like this. He will give you the system, and the question would be determine if each ordered pair is a solution of the system. So is 4 and -1 a solution of this system? So simply you replace x by 4 and y by -1 in the first equation. So 4 plus 2 times -1. What is this? It's 4 minus 2. It is equal to 2. So the first equation is true, satisfied. Now the second equation, x is 4 minus 2 times y, which is -1. So this is 4 minus times minus plus 4 plus 2, which is equal to 6. So this is also true. So yes, 4 and -1 is a solution of the system. What about -4 and 3? Is it a solution of the same system? Okay, so let us replace x by -4 and y by 3. So the first equation, we will have -4 plus 2 times 3. This is -4 plus 6 equals 2. So the first equation is true. Let us check the second equation. X is -4 minus 2 times y, which is 3. This is -4 minus 6. This is -10. It is not equal to 6. -4 and 3 is a solution of the first equation, but it is not a solution of the second equation. So -4 and 3 is not a solution of the system. if an ordered pair satisfies one of the equations, then it is a solution of that equation, but it is not a solution of the system. It has to satisfy both equations to be a solution of the system. Please solve this question. Check whether 1, 2, 7, 6 are solutions of this system or not. Also do this one. Determine whether this ordered pair 2 and 5 is a solution of this system or not. Now, the solution of a system of linear equations can sometimes be found by graphing both of the equations. We said that this equation x plus 2y equals 2, the graph of this equation is a straight line. So if you graph this equation, this would be the graph, the blue line, okay? This is the graph of the first equation. The second equation is also a line. This is the graph of the second equation. So where is the solution? The solution is the intersection point, this point here. The intersection point, 4 and -1. 4, x is 4, y is -1. So you can see that the solution is the point or the ordered pair 4 and -1. So 4 and -1 satisfies the first equation. It passes by the first line and it passes by the second line. So it will satisfy also the second equation. So 4 -1 is the solution of the system. So sometimes you can find the solution by graphing. Anyway, the solution of the system would be always the point of intersection between the two lines. Now, the first method we are going to learn to solve linear systems is substitution. So we will eliminate one of the variables using substitution method. Sometimes by graphing is not possible because the solution could be like this, for example. How can you find this solution using graphing? So no way. So it would be difficult. So the intersection point is the solution, but how can you find the coordinates of the intersection point? You need a method, and this method will be called substitution method. Okay, how to solve, how to use this method? Well, this method, in this method, we convert the system. What do we have in the system? We have two equations. We convert the two equations to one equation in one variable. So instead of having two equations of two variables, we have one equation, and in one variable, we solve this equation and we find the value of x or y, then we find the value of the other variable. So we solve, these are the steps. You choose one of the equations, either equation 1 or 2, and you solve this equation for one variable, for x or for y. Okay. If one of the equations is already in this form, if one of the equations is solved for x or y, then this step can be skipped. So for example, here, the two equations are not solved for x or y. Okay, here also, look here. The second equation is solved for y. That's good. So you can use this equation now, use this value of y, and put it in here in the first equation. So from the second equation, I know that y is equal to 2x minus 9. So I immediately go to the first equation. I replace y by 2x minus 9. So this is substitution. I am substituting the value of y from the second equation in the first equation, equals to 8. Now I have one equation in one variable. So I solve this equation and I find the value of x. So expand, 3 times 2 is 6x, minus 3 times 9 is -27, equals to 8. This is one equation, linear equation. So 6 plus 1, I have 7x, and I'll take 27 to the other side. So 27 plus 8, this is 35. And now I divide by 7. So x is 35 over 7, which is 5. So x is 5. Now, how do we get the value of y? Now I go to the second equation and replace x by 5. So I will have 10 minus 9, 1. So the solution set of this system consists of the ordered pair x is 5, y is 1. That's the solution. And you can check the solution. You can replace x by 5 and y by 1. So 5 plus 3 times 1 is 8, correct. And 2 times 5, 10 minus 9 is 1, correct. So actually this is the solution of the system. So this is the substitution method. If one of the equations is already solved for one of the variables, you skip the first step. Then you substitute the expression found in step 1 into the other equation. Okay? You solve that equation for one of the variables, as we did for x. Then using back substitution, you get the value of the second variable, and then you check your answer. Now you may ask yourself, in the first step, okay, of the substitution method, how do I know which variable to isolate and in which equation? So which variable to solve for, okay? Which equation should I should I use? Which variable should I solve for? Here, a hint, you can choose both the variable and equation. It's okay. You can do this using any equation or any variable, but it would be easier for you, if possible, solve for a variable whose coefficient is 1 or -1. So if one of the variables has coefficient 1 or -1, you solve that equation for that variable. So if you look here to example 2, the coefficient of x is 5, the coefficient of y is -4 in the first equation. So it's not 1 and -1. But in the second equation, the coefficient of x is 1. So that's good. You can just solve the second equation for x. So you take 2y to the other side. So x would be 2y minus 3. Close the mic, please. And now you have x equals 2y minus 3. You put it in the first equation. So you multiply 5 times 2y minus 3 minus 4y equals 9. So this is substitution. I solve one of the equations for one of the variables, and then I substitute this variable in the other equation. I have one equation in one variable. I solve this equation. So I need to distribute 5 times 2, 10y minus 3 times 5 is 15 equals 9. Now 10y minus 4y is 6y, and you take 15 to the other side. 15 plus 9 is 24. Now you divide by 6. Y would be 24 over 6, which is 4. So now you have y. You go to this equation and you replace y by 4 to get the value of x. So 2 times 4, 8 minus 3, 5. So the solution set would consist of the point x is 5. You always start with x, and y is 4. So that's the solution set of this system. And you can check that actually it is a solution. So 5 times 5, 25, minus 4 times 4, 16. 25 minus 16 is actually 9, and 5 minus 2 times 4, 5 minus 8 is -3. So this ordered pair satisfies both equations, so it is the solution of this system. Please try to solve this system, and notice that the coefficient of y here is 1. So you will start by taking 2x to the other side, solving the second equation for y, and then substitute this in the first equation, find the value of x, then go back here and find the value of y, then find the solution set of this system. Here also, you can solve the second equation for y, okay? You can take actually y to the other side and bring 11 here. So y is 3x minus 11. So you can use this fact that y is 3x minus 11. Or if you want, you can keep the negative here and take minus 3x to the other side. And then you multiply by negative 1. So you will have y equals 3x minus 11 in both cases. And then you replace y in the first equation by 3x minus 11, find the value of x, and go here and find the value of y. That would be the solution of the system. Here, what do you need to do here? Well, I need to first simplify the equations. Write the system, write each equation in the form ax plus by equals to c. I have negative 2x here. Take it to the other side, so it would be 2x plus 2x. You will have 4x. So 4x minus 3y equals to 8. And if you take x to the other side here, it would be 3x minus x, so it would be 2x. And 4y minus 3y, it would be plus y equals to 14. So this is the first step here. You write each equation in the form ax plus by equals to c, and then you see that you can solve the second equation for y, and you put it in the first equation, and you find the value of x, and then you find the solution of the system. Now let us look to this question, question 17. The first equation is solved for y. The second equation is also solved for y. So y equals this and y equals this. So I can immediately say that 1 over 3x plus 2 over 3 equals 5 over 7x minus 2. So this y equals to this y. So I have the right-hand side here equals to the right-hand side here. And I have an equation in one variable. Now I need to solve this equation. To solve this equation, I need to get rid of the denominators. I have 3 and 7. So I will multiply by 3 times 7, which is 21. Okay. So I will multiply each term by 21. So 21 times 1 over 3x plus 21 times 2 over 3 equals 21 times 5 over 7x minus 21 times 2. Okay, so 21 divided by 3 is 7, so I have 7x. 21 divided by 3 is 7. 2 times 7 is 14, so this is 14. You can use the calculator if you like to multiply 2 over 3 times 21. 21 divided by 7 is 3 times 5, that's 15. Okay, minus 21 times 2, that's 42. So now all the denominators disappeared, and you can take x to the other side. So 7x minus 15x equals negative 42 minus 14. You can take also 14 to the right-hand side. So negative 8x is equal to negative 42 plus 14, and that's 56. And now you can 56. Now you can solve this equation for x. So it would be negative 56 over negative 8, and that is 7. So x is 7. Now you have x. Now how to find y? You can use the first equation or the second equation to find the value of y. But if you look carefully, the first equation is 1 over 3 times x. The second equation is 5 over 7 times x. So if I use the second equation, I will multiply 5 over 7 times 7 minus 2. So 7 will be cancelled with 7, and 5 minus 2 will be 3. So I will get y easily. So the solution set of this equation would be the value of x 7 and the value of y is 3. That's the solution set. Notice that there is a mode in the calculator called equations. If you press that mode, you have the first number 1, a in x plus b in y equals cn. you can use this to solve the system. So for example, but the system has to be written in this form. You have to solve the system while it is written in this form. It has to be written in this form. So if you want to use it to solve this, you have to write it in that form. Okay, you have to write it like this: 1 over 3 x. If you take it to the other side, it would be negative, plus y equals to 2 over 3, and negative 5 over 7x plus y equals to negative 2. And then you put these numbers in the calculator: negative 1 over 3, 1, 2 over 3, negative 5 over 7, 1, and negative 2. And the calculator will give you the answers 7 and 3. You can use the calculator to check your answer, but you have to show your steps. The third objective in this section is how to solve linear systems by addition. So the first method is substitution. The second method is the addition method. We here in this method also eliminate one of the variables. So we will get one equation in one variable, similar to substitution, but we will use a different method called addition method. Okay. How? Here we add the two equations. Here we add the two equations. We eliminate one of the variables by adding the two equations. How? If you have this system, for example, look to this system. This is the first equation. This is the second equation. What happens if you add these two equations? 3x minus 3x, 0. They cancel. Negative 4y plus 2y, you have negative 2y equals 11 minus 7, that's 4. So when you add these two equations, one of the variables will be disappeared. Why? If you look carefully, the coefficient here is 3, the coefficient here is negative 3. So whenever this happens, if one of the coefficients is a and the other one is negative a, then when you add the two equations, this variable will disappear. So now you can divide by negative 2. Y would be 4 over negative 2. That's negative 2. And you can use any of the equations. For example, the first equation, I substitute y with negative 2, and I solve this equation, and I find the value of x. So I have here plus 8. If you take it to the other side, it would be negative 8. That's 3. So 3x equals 3, or x equals 1. So the solution set of the system would be 1x, and y is negative 2. So this is the addition method. All right. So when we obtain, we need the coefficients to be differ only in sign. So the coefficients of the variable that we need to eliminate. Okay. If you want to eliminate x, then the coefficients of x should be differ only in sign. 4, negative 4, 3, negative 3. If you want to eliminate y, then the coefficients of y should be differ only in sign. Negative 4, here 4. 2, here you should have negative 2, and so on. That's the method, okay? So we rewrite both equations in this form if necessary, if it is not given in this form in the equation. And then we multiply either equation or both equations sometimes by an appropriate non-zero numbers, so that the sum of the x coefficients or the sum of the y coefficients is 0. The coefficients of x differs in a sign, or the coefficients of y differs in a sign. How to do this? For example, here, when we solve this, if you want to solve this system by addition method, the coefficient of x is 2, the coefficient of x is 8 here, and this is 10 and this is 5. So you cannot add. You have to change one of these coefficients. So here the question, we can eliminate y. If you want to eliminate y, if this coefficient is 10, then this coefficient has to be negative 10. Okay? So what to do? What to do? You need to multiply the second equation by a number. How to find this number? You need it to be negative 10. Divide negative 10 by 5 so you will have -2. So we can eliminate y by multiplying the second equation by -2 and then adding the equations. So the first equation is 2x plus 10y equals 9. Now, if you multiply the second equation by -2, you will have -16x, -10y equals to -14. And now if you add the two equations, y will be cancelled and you will have -14x equals to -14 plus 9, which is -5. So now you can find the solution, the answer, the value of x, and then you substitute and in any of these two equations and find the value of y. A question: do we have to eliminate y here? No, you can eliminate x. Okay, to eliminate x, what should we do? I have 8 here and 2 here. So if you divide 8, I need this 2 to be -8. If you divide -8 by 2, you have -4. So you need to multiply the first equation by -4 to eliminate x. Another example, when solving these two equations, okay? Now look to the variable. Look here, 4, 3, 3, 2. These are the coefficients, okay? By the addition method, we can eliminate y. Now to eliminate y, we need, for example, this is -3, this is -2. We need it to be 3. So if you divide 3 by -2, you will have a fraction. So we don't need to change any of the equations to fractions. We don't like fractions. So what can we do? Well, in this case, I can multiply the first equation by a number and the second equation also by a number. So look here, by the addition method, we can eliminate y by multiplying the first equation by 2. If you multiply the first equation by 2, okay, what would you get? The coefficient of y would be what? What would be the coefficient of y? We will have 8x minus 6y equals to 30. All right. So the coefficient of y is -6. Now you need the coefficient of y in the second equation to be 6. So the second equation, what would you multiply the second equation by? Which number? So the coefficient of y would be 6. It is 3. If you multiply the second equation by 3, you will have 9x minus, no, you need -3. 3 is not good because it will make it -6. I need it to be +6 so I can eliminate when I add the two equations. So -9, because I'll multiply by -3 now, plus 6y equals -3 times 10, that's -30. Now, if you add the two equations, y would be cancelled, and you will have 8 minus 9, -x equals 0 in this case. So this is what he meant here by sometimes you multiply either one of the equations or both equations. So the coefficients of x will differ in sign, or the coefficients of y would differ in sign. Add the equations, and the sum of the equations would be, the sum would be an equation in one variable. You solve that equation, use back substitution to solve for the other variable, and then check your answer. Let us solve this system. I'll leave this for you because here it is easy. This is 9x. This is, I will eliminate y here, okay? Eliminate y. Why I chose to eliminate y? Because the coefficient is -8, the coefficient is 2, so I need to multiply equation 1 by 4. If you multiply equation 1 by 4, you will have 12x plus 8y equals 4 times 48. That's 192. And the second equation as it is, So now, if I add the two equations, y will be cancelled. And if you add 12x plus 9x, you get 21x. And if you add 192 plus negative 24, you get 168. So x is 168 over 21, and that's 8. So you have the solution of one of the equations. Now you can go to the first equation, for example, replace x by 8 and solve this equation and find the value of y. So 2y would be 48 minus 24, 24, or y is 12. So the solution set of this system would be 8 and 12. So this is the addition method. Please use the addition method to eliminate x here. I advise you to eliminate x here by multiplying which equation? Equation 2 by what? This is 4. I need this to be negative 4, so I'll just multiply equation 2 by negative 2. Some linear systems have solutions that are not integers. So here the solution is 8, 12. These are integer numbers. But sometimes the solutions are not integers. So if the value of one variable turns out to be a messy fraction, it's a fraction, you can return to the original system and use the addition method to solve for the other variable. Okay, let us do this here. Now, I will first write this system in this form: 2x minus 7y equals negative 17. And I'll take negative 3x to the other side, so it would be 3x plus 5y equals 217. So I wrote the system in this form: ax plus by equals c. Now, to eliminate x, if I need to eliminate x, I will multiply the first equation by negative 3 and the second equation by 2. So if you multiply the first equation by negative 3, you will have negative 6x plus 21y equals negative 3 times 17, negative 17, that's 51. So this is the first equation after multiplying by negative 3. Now the second equation, if you multiply by 2, you will have this equation. 17 times 2 is just 34. Now you have the coefficients of x differ in sign. So if you add, you will have 21 plus 10, that's 31y, and 34 plus 51, that's 85. Now y is 85 over 31, and that's what he meant by a messy fraction. It could be difficult to replace y here, for example, by this and solve for x. If you want, you can stop here and now go back to the original equations and change, now multiply the first equation by a number and the second equation by a number, so that in this case you eliminate y and not x. So if you multiply here by 5 and here by 7, you will get the following: 2 times 5 is 10x, minus 7 times 5 is minus 35y, and 17 times 5 is negative 85. The second equation, multiply by 7, 21x plus 35y equals 17 times 7, and that's 119. Now you can see that if you add, y will be cancelled, and you will have 31x equals 119 minus 85, and that's 34. So what is the value of x? X is 34 over 31, so that's the solution set of this system. X is 34 over 31 and y is 85 over 31. Please do the same to solve this exercise, and also practice the addition method by solving these three exercises. I stop here, and tomorrow, inshallah, we will continue this section. If you have any